Welcome to Spark Academy students. Once again welcome to our Spark Academy. Welcome to online class Spark Academy. Let us learn about group 16 elements today. Our topic is group 16. Tell me, which block elements group 16? S, P, D, Group 16 elements are P block elements. We are learning P block elements like 13, 14, 15, 16, 17 and 18 groups. Today we are going to learn 16th group elements. Before that, about our Spark Academy, education, A19 media education, courses and offerings, JEE, NEET, NEET, bridge course, foundation classes. In that, free study material, free previous year questions, free videos, exclusive live classes, chapter wise test, full length tests, doubt clarification sessions, daily preparation for exam, weekend exams, daily exams, depends on the DPPs, subject wise content. Subject wise content also available in our Spark Academy, mathematics, physics, chemistry and biology. Live classes, see some examples of live classes here. Animal kingdom revision, digital electronic, chemical equilibrium, kinetic theory of gases. Like our class also available. Groups, chemistry, organic, physical. Assignments also available, everyday assignments. For example, 15th April doubts created by Krishna. So 15th April assignments, plant kingdom biology and April assignments also. By this way assignments also we are doing regularly. Coupon also available for you. Yes, not only outside, some other side coupons not here in our Spark Academy also coupon is there, 50% off, Spark 50, use this, hurry up. And JEE 2021 short term courses, up here preparing for the JEE 2021 and NEET 2021 short term, 7 free content inside is there, 13 free content inside is there, EAMCET 2021 short term, JEE EAMCET EAMCET also available, study materials, preview available, courses, everything available. That also depends on what discount also available. So call students on these numbers given here. Yes. Now come to our topic. What is our topic today? Our topic is oxygen family. 16th group elements. In that first one, oxygen. 16th group elements. First one is which one? Oxygen. Oxygen, sulphur, selenium, tellurium, polonium. 16th group, otherwise 6th A group. Yes. 16th group. 6th A group. These are called oxygen family. 16th group members. These 16th group members are called chalcogens also. What? Chalcogens. 16th group elements, chalcogens. So what are first one is oxygen, second one is sulphur, selenium, tellurium and polonium. These are 16th group elements. So now what is our work? Now can we write their electronic configuration? Yes. So electronic configuration, before that we see the brief information about them. As if see their electronic configuration, means general electronic configuration is NS2 and NP4. So how many valency electrons? 6 valency electrons present in every element in 16th group. They are diatomic. All not. Oxygen first. What is the first element in 16th group? Oxygen. Oxygen exists diatomic. What is the atomicity of oxygen? Oxygen atomicity is 2. It exists in diatomic. What about remain while sulfur, selenium, tellurium, they exist octaatomic. What is the atomicity of the sulfur? S8. What is the atomicity of selenium? 8. What is the atomicity of tellurium? 8. They have 8 atomicity, which have ring structure. Structure also their structure, ring structure. Yes, they contain ring structure. Yes, come to oxygen and sulfur. What their physical nature? Oxygen and sulfur, they are non-metals, gaseous state. Oxygen is gaseous state, sulfur is solid state, but both are non-metals. Next, take selenium, tellurium. Elements become increasingly more non-metallic towards the right hand side of the periodic table. We know that. Next, come to the selenium, tellurium. They are semi-metallic behavior. Selenium, tellurium, they are semi-metallic behavior, and polonium exhibit metallic character. See students, the group members oxygen, sulfur, selenium, tellurium, polonium, starting no metallic nature. Down the group metallic nature is increases. Then we say the polonium exhibits metallic nature. Oxygen non-metallic nature. Oxygen diatomic, gas, remain or solids. Oxygen and sulfur have the most significant chemistry in the group. Oxygen, sulfur, they have more importance. Oxygen you know very well, and oxygen is the more reactive. So reactivity also more for oxygen. So once again, oxygen, sulfur, selenium, tellurium, polonium are called chalcogens or 16th group elements or 68 group elements. What is the general electronic configuration? NS2, NP4. Valency electrons 6. Now we see there electronic configuration. Before electronic configuration, this oxygen 1/5 atmosphere, most abundant element in the earth crust. How much? 1/5 earth atmosphere. Now sulfur is yellow non-metal solid, smells like rotten eggs. In eggs, the yellow color pot contains sulfur. Selenium is a non-metal solid, conducts electricity with sunlight. And tellurium, polonium are metalloids. So polonium is metallic nature, tellurium, selenium, they are which nature? They are in metallic nature. Oxygen. The second one, sulfur. What about third one? Selenium. Next one, tellurium. Last one, polonium. Now come to the electronic configuration. What is oxygen electronic configuration? We take with the help of helium. Helium, neon, noble gases, argon, krypton, xenon. So helium is 1s2, then 2s2, 2p, 1, 2, 2, 4, 2p4. See the electronic configuration. 2s2, 2p4. Neon 10, 3s2 and 3p4. What about atomic number? 8, 16, 34, 52, 84. Now 10 to 12, 4. 4s2. Next 4p4. Which one it is? Selenium. Argon 3d10, 4s2. 3d10, 4s2, 4p4. 4d10, 5s2. Here 4f14. 5d10. 6s2. 6p4. Here 5s2, 5p4. Now see there. Valency electrons. What about valency electrons here? 6, 6, 6, 6, 6. So valency electron 6. Valency electrons. So what about valency? Valence electrons means we know for as known factor what? Valence electrons means outermost orbit electrons. What about valency? Combining capacity. These elements are non-metals, more electronegative, then they gain electron, their combining capacity is 2 because already 6 electrons there. 2 electrons required to get stability. Now come to the physical state. Yeah, physical state already stated. Oxygen is gas, sulphur is solid, selenium solid, tellurium solid, polonium also solid. So atomic numbers completed. And come to the isotopes. Yeah, oxygen, sulphur, selenium, tellurium, polonium, they possess isotopes. Now atomic mass. Yeah, atomic mass increases. And come to the atomic radius. Atomic radius also increases down the group. Up to tellurium increases again. In the case of the polonium, decreases. Yeah, melting boiling points. Melting boiling points also increases down the group. Yeah. Now come to the special properties like catenation. Yes, these group elements they shows catenation nature also. As what is catenation? Self-linking. Yeah, catenation. Yes, these are showing catenation nature. Yes, catenation. In that catenation, first of all, oxygen has less. Oxygen shows catenation like HOOH, H2O2. Yes. And next come to the sulphur. Sulphur is showing yes, H. It is H2O2. It is H2S2. Hydrogen sulfur. Yes. Same time HSS means H2S3. So these are called catenation nature. This group elements oxygen has less catenation nature and sulfur showing little bit high compared with oxygen catenation nature. After catenation nature, catenation nature we see the allotrophy nature. These group elements they shows allotrophy. Yes, allotrophy nature also. What is allotrophy? What is the meaning of allotrophy? Yeah, allotrophy means they exist more than one form, like carbon existing more forms. Same way oxygen exists. Yes, dioxygen and ozone. Yeah, come to the sulphur. Sulphur is exist rhombic sulphur, monoclinic sulphur, plastic sulphur. Yes, these are the forms. Selenium, yes, red. Selenium is red and grey. Selenium. After selenium comes the tellurium, metallic and non-metallic. Metallic and non-metallic. Come to the polonium, alpha and beta. These are the allotrophic forms of the 16th group elements. 16th group elements they are showing allotrophic forms. All oxygen O2 O3, sulfur, rhombic, monoclinic, plastic, selenium, red and grey, tellurium, metallic, non-metallic, polonium, alpha, beta. By this way, these group elements exhibiting allotrophic nature, exhibiting their allotrophic nature. Yes. After allotrophic nature, now we discuss the oxidation state of these elements. This shows oxidation state. Yeah. Oxidation state of these group elements, oxygen. Oxygen oxidation state is -2 generally, -1 in peroxides, -1/2 in superoxides. Come to the sulfur, yes. Yeah, remain elements, Remain elements, sulfur, selenium, tellurium, yes, and polonium, They exhibit oxidation state +2, +4, +6. These are oxidation states. So clear the oxidation states. After oxidation state, now hydrides. These group elements, they are forming hydrides. Yeah, hydrides. Like oxygen hydride, sulphur hydride, yes, selenium hydride, tellurium hydride, yeah, polonium hydride, yes, forms hydrides. Yeah. So what about hydrides? Yes, hydrides these are. Now H2 is liquid, others are colorless, foul, smelling toxic gases. Bond length increases down the group in the case of the hydrides. Bond energy decreases down the group. Volatile nature decreases. Ability to act as reducing agent, acidic nature increases down the groups in the case of the hydrides. These group elements all are forms hydrides. What is the hydride of oxygen? Water. What is the hydride of sulphur? Hydrogen sulfide. What is the hydride of selenium? Hydrogen selenide. What is the hydride of tellurium? Hydrogen tellurinide. Hydrogen polonide. These are the hydrides. Now we see the acidic strength of these hydrides. Which is strength? Acidic strength. Yes, acidic strength H2O less than H2S less than H2SE less than H2P less than H2PO. Yes, these are acidic strength H2O. Yes, H2S, H2SE, H2PS, H2PO. So acidic strength water is less than hydrogen sulfide. So hydrogen polonide has more acidic strength. Water is less than, yeah, by this way. Reducing nature, yeah, they are good reducing agents also. But reducing nature decreases down the group. Yeah, see the reducing nature decreasing. Thermal stability, yeah, thermal stability, yes, thermal stability is decreasing. Yes, H2O greater than H2S, thermal stability. So acidic nature increasing, reducing nature increasing, but thermal stability, yeah, decreasing. So these are the very important in the case of hydrides of 16th group elements. After hydrides, oxides. Yeah, they forms oxides also. What are two types of oxides? MO, monoxide. Yes. Next one, yeah, MO is monoxide. MO2, yes, dioxide. Like we take the oxides like TiO3, tellurium oxide, yes, selenium oxide, yeah, sulfur trioxide. Now what about their nature? Acidic nature. Yeah, this one is less than this one. This one is less than this one. Yeah, acidic nature oxides. These are forms oxo oxides also. What is the meaning of oxo acids or oxo acids? Means this group elements intertwine with hydrogen. Oxygen also forms compounds. They are called oxo acids. Yeah, H2SO3 sulfurous acid, H2SO4 sulfuric acid. Yes, by this way H2S2O3, H2SO5, yes, H2S2O8, H2S2O7, yes. By this way they are forming oxo acids. Sulfur has ability to form oxo acids because for sulfur available d orbital availability is there. It extends its valency. It forms oxo acids. Yes, after oxo acids, this group elements forming halides also. They compact with halides. Forms, yeah, oxygen difluoride. Yes, oxygen, chlorine dioxide, bromine oxide, dibromine oxide, sulphur, sulphur dichloride, sulphur dichloride, yes. By this way, sulphur forming, sulphur, yeah, yes, Br2, S2Br2, SF6. Selenium also SCF4 and tellurium SCF6. Yeah. These group elements, they forms what? Halides. Yeah. Oxygen difluoride, chlorine oxide, bromine oxide, sulfur difluoride, selenium sulfur dichloride, sulfur trichloride, sulfur bromide, sulfur hexafluoride, selenium hexafluoride, tellurium hexafluoride. They forming, yes, what? Oxides. Now tell me, which is the first element in this group? Yeah. Which is the first element in this group? Yes, oxygen is the first element in this group. Then oxygen is showing anomalous properties, means different character. Why? Because oxygen is small size. If see the radius, oxygen atomic radius is small. Next, more electronegative, high ionization potential. Yeah, now we check the ionization potential. Yes, ionization potential is very high. Yes, for oxygen. High electronegative character and no available of the d orbital. Not available of the d orbital. And hydrogen, oxygen has only allotrophic forms. Yeah, these are what? Anomalous properties of the oxygen. So oxygen is the element showing exceptional behavior in this group. Exceptional behavior in this group. Yeah. So oxygen is the first element. Yeah. Now can we learn? Yeah, we learn the oxygen preparation. What are the preparation methods of the oxygen? Yeah. Oxygen preparation methods. In the first one, yes. So first, occurrence, oxygen, yeah, oxygen available how much? 21% by volume. Yeah, it is available 21% by volume in the atmosphere, in free air. So preparation, first preparation is which one? Yeah, KNO3, potassium nitrate. Yes, undergoing heating, potassium nitrate, and forms potassium nitrate plus oxygen. Yes. Now balance. How many oxygens? 2. Yes, 2. 3 to the 6. We have 3 there. Yes. 2. 2 to the 4, 5, 6. Yeah. Balance. Yeah. See this one? Yeah. Potassium nitrate on heating, it giving potassium nitrate and releases oxygen. And take the KClO3 also. Yes, it is a laboratory preparation. Potassium chlorate. Yeah, we are taking potassium chlorate. Potassium chlorate on heating. Presence of MnO2, manganese dioxide. It gives KCl plus O2. Yes. 2 O2s. Then I take 2. 3 to the 6. Already 2 there. Yeah. 3 to the 6. Then how many 2? Yes. Now balance. Yes. These two are preparations of the oxygen in the lab. Potassium nitrate and potassium chlorate. Potassium nitrate and potassium chlorate. Yeah. KClO3, MnO2 gives rise to KCl and O2. Yes. By this way we prepare from other methods also, like dioxides, AgO. Yes. Ag2O, dioxide. On heating it gives Ag plus O2. Ag plus O2. How many Ags? 2. Oxygens 2. Yes. Yeah, then 4 Ag. By this way dioxide. Same time to take MnO2. From MnO2 also we prepare Mn3O4 plus O2. Yes. Yes. How many? 3 Mn. 3 to the 6. for that to balance. Yeah, these are the preparations of that. Which one is laboratory method? Yeah, this method is called lab method. It is laboratory method, preparation of the oxygen. Yes, preparation of oxygen by the lab. Potassium chloride and potassium chloride is laboratory preparation. Yes. Yeah. Now come to the industrial method. Yeah. For industry also the oxygen is very important. Yeah. Industrial method also present. In industry oxygen is very important. Yeah. Industrial purpose, how we prepare? From air. Yes. From air we prepare. From air how? Fractional distillation. From here how? The fractional distillation. Yes. Fractional distillation. By fractional distillation, we prepare or manufacture oxygen. Same time from water also. Yeah, take the water. What is the water? H2O water. Yes. On electrolysis, water on electrolysis gives H2 plus O2. So how many 2? 2. Yes. H2O2. It is a preparation of the what? Oxygen from water also. Yes. These two are industrial methods. Industrially we prepare from air oxygen by fractional distillation. From water on electrolysis also we prepare. Yes. These two. Next come to the physical chemical properties of the oxygen. Yeah. Yes. In that first one. Yes. So describe the physical characteristics of the substances. 5 senses: texture, hardness, luster, odor, sounds. Phase and room temperature. Next, numerical description: density, melting, freezing point, boiling point. Yes. Now here, these are the physical properties of the oxygen. Yes. What is the atomic radius? Yeah. Now come, yes. Yeah. What about the chemical properties? Atmospheric oxygen. They give us the chemical properties. Now we see one by one. What is the physical properties in that? It's physical properties means we speak about the only dioxygen. Yes. Dioxygen atomic radius PM. How much? 73. Yes. What about electronegativity? 3.5. Its electronegativity is 3.5. Yes. Ionization potential IE. Ionization enthalpy is what? 1310 kilojoules per mole. Yes. Electron affinity is 140. Yes. These are the physical properties. Atomic properties. Yeah. Molecular properties. What is the bond length? Its bond length is 120. Yes. Yeah. Bond length is 120. So chemical physical properties of the oxygen. Yes. So if you see the chemical properties of the oxygen. Oxygen chemical properties. Chemical properties of the oxygen. Yeah. So it does not burn itself. Oxygen does not burn itself. It supports burning. It's quite stable and it is very reactive O2, and it forms atomic oxygen. Easily it forms atomic oxygen. Yes. It forms easily atomic oxygen. Yeah. Now come to the reaction with metals. Yeah. Sodium. Yes. Oxygen reacting with metals like sodium. Sodium plus oxygen forms Na2O. How many oxygens? 2. 4 sodium atoms required here. When sodium reacting with highly electropositive metal sodium like sodium forms oxides, they are in basic in nature. Such oxides, they are presented basic in nature. Say calcium oxide, you take Ca plus O2, then gives rise CaO. Yes, 2 moles, 2 oxygens here, 2 moles of CaO. By this way, sodium oxide, calcium oxide, they are strong basic nature. Such oxides are called basic oxides. Can we see with aluminium? Yeah, Al plus O2 gives rise Al2O3. Aluminium trioxide. Aluminium trioxide, how many? 2. Then 2 to 4. Yeah, 3 to the 6. Yeah. So now aluminium oxide is neither acidic nor basic. Means is it neutral? No. It is amphoteric. So sodium, calcium, they are strong. They are electropositive metals. Aluminium also electropositive, but aluminium oxide is amphoteric. It reacts with acids, bases. Such oxide is called amphoteric. Yeah. Now come to the iron. Yes. We take with the iron Fe plus O2 gives rise. Yeah. Fe2O3. Yes. Iron oxide. How many iron molecules see there? 4 we take here. Yes. Then 3 to the 6. Yeah. By this way. Yeah. So by this way, oxygen reacting with metals like sodium, calcium, aluminium and iron. At the same time, this oxygen reacts with non-metals also. Non-metal like H2. H2 plus O2 gives rise H2O. Yes. Both gases given liquid. Yes. So how many? 2 H2O. Yes. 2 to the 4. Yeah. This is electrical discharge tube. This reaction takes place same way. S plus O2. Sulphur also burns with oxygen, forms sulphur dioxide. Same time carbon with oxygen, S forms carbon dioxide. So oxygen reacting with metals and non-metals. When metals, corresponding metallic oxides. When non-metals, corresponding non-metallic oxides. Now what is the nature of this non-metallic oxide? Yeah, tell me. Yeah, acidic. Yes. What about this? This is neutral. Now take one more. Yeah. One more. Which one? Yes. Take N plus O2 gives rise. N2 plus O2 gives rise NO. Nitric oxide. Yes. Nitric oxide. Yeah. So these are the chemical properties of the oxygen. Yes. Now we see more chemical properties of the oxygen. Yes. It reacts with O2 reacts with HCl, hydrochloric acid. Oxygen reacting with HCl, hydrochloric acid forms H2O plus Cl2, chlorine gas. Yeah, see that. So here how many? Yeah, O2 is 2. I take 2. Then here how many? 4 HCls. Then chlorines become 2. Balance. Yeah. Next, yeah, CS2. Otherwise, we take CH4. What is CH4? Methane. CH4 is the hydrocarbon. CH4 is the hydrocarbon. Methane means hydrocarbons. They undergo combustion, forms carbon dioxide, water, along with releases energy. So hydrocarbons are called fuels. They releases energy. Now balance the reaction. Yes. 2 O2 we take. Yes. 2 here 2 4. Hydrogens 4, carbon 1. Yes. By this way, oxygen combines with compounds like HCl is a compound and same time here methane also compound. By this way, like carbon disulfide, it reacts with carbon disulfide. Yes. It's react with here ammonia also. By this way, carbon disulfide and ammonia. Now come to the uses of the oxygen. What are the uses of the oxygen? Oxygen is very essential. Yeah, it is called living gas, very useful to life. Next, oxyacetylene flame. What is oxyacetylene? Oxyacetylene flame. This oxyacetylene flame or oxyacetylene torch very useful in welding to cut the metals. Yeah, metal plates, metal rods. For that, oxyacetylene flame or oxyacetylene torch is very useful. Liquid oxygen useful as a fuel. Liquid oxygen useful as a fuel for rockets. And oxygen acts as a good oxidizing agent also. It is good oxidizing agent. And bleaching agent. Oxygen acts as a bleaching agent. Yeah. Next, rocket fuel, and it is very useful in metallurgical operations. What are metallurgical operations? extraction of the metals. Several metals very important in our daily life, economical importance there. Such metals we extract from their ores. That entire process is called metallurgy. Extraction of the metals, in that oxygen is very useful. Yeah, it removes the impurities. How it acts? Oxygen removes the impurities from the ores and makes the pure metals. So oxygen acts as a good removal of the impurities in metallurgical operations. Now come to the compounds of the oxygen. What are the important compounds of the oxygen? Yeah, oxygen main compound is ozone. What is the formula of ozone? O3. Where is present ozone? It is present in stratosphere. It protects from us, from Earth, UV rays, ultraviolet rays. Because ultraviolet rays very dangerous to life form. Ultraviolet rays causes cancer. For that, ozone acts as a blanket. It protects for us from UV rays. Ozone, O3. So preparation of the ozone. How we prepare the ozone? Preparation of the ozone. Ozone is called allotrophic form of the oxygen. Now preparation of the ozone. Yeah. Take the O2 oxygen. Yes. In silent electric discharge tube. That is called ozonize. That is called ozonizer. So we are using two types of ozonizers preparation of the ozone. Okay, two types of Siemens and Brody. These are the ozonizers useful to preparation of the ozone, because here tube is required. Ozonizer, ozonized tube. In that silent electric discharge tube, that is called, in that oxygen, that on heating it gives O3. How many moles? 2 moles. How many moles required? O2, 3 moles. Yes. Now here, this reaction, heat of reaction is positive. So heat of reaction positive indicates what for us? This reaction is endothermic reaction. This reaction is endothermic reaction. Endothermic reaction. Endothermic reaction. This reaction is endothermic reaction. How much energy is used here? 142 kilojoules energy. Yes. So why we are using here silent electric discharge tube? Because silent electric discharge tube prevents the decomposition of the ozone. Yes. And if concentrates of ozone greater than 10% are required, a battery ozonizers can be used. Just now I said for this process required ozonizers. Ozonizers. Yeah. Two types of ozonizers we are using preparation of the ozone. It is the preparation of the ozone. Yes. Yeah. So now come to the, what are the physical properties of the ozone? Yeah. Ozone, yeah, ozone physical property. It is a light blue colored gas having pungent odor. Yeah, its vapor density is 24. Yes, it is slightly soluble in water. And come to the chemical properties. Ozone undergoing decomposition. Yes, ozone undergoing decomposition and forms oxygen. Ozone, O3. On heating it undergoing decomposition forms O2, 2 here 3. Yes. Balance. Yeah. Yes. Next, it acts as a oxidizing agent. O3 acts as a oxidizing agent. O2 and plus O. It releases O, oxygen. This oxygen is called nascent oxygen. So you are releasing nascent oxygen from this reaction. Nascent oxygen is released. See this ozonizer and electric discharge tube, total setup, how it is present preparation of the ozone. Now see the structure of the ozone here. Ozone has two resonant structures. So they are called canonical structures of the ozone. So ozone, example for covalent, but in that coordinate covalent bond also present. Coordinate covalent bond also present. Yes. And ozone reacts with mercury. Hg plus O3. Ozone reacting with what? Mercury. Hg plus O3 gives rise Hg2O plus O2. Yes. Now how many are 2? So this is called mercuric oxide. Yeah. This mercuric oxide is called meniscus because when mercuric oxide will form, the movement will stop the mercury. So it is called tailing of the mercury. It is called tailing of the mercury. Otherwise, meniscus. It is called meniscus. Otherwise, tailing of the mercury. By this way, ozone acts as an oxidizing agent. Ozone undergoing decomposition. Ozone reacting with mercury. And ozone forms ozonizers. Ozone forming what? Yes. Ozone forming ozonides. Ozone forming ozonides. What are ozonides? What are ozonides? Yes. What are ozonides? Like ethylene, CH2, double bond CH2. It reacts with ozone and forms what? Ethylene ozonide. Yes. H2CH2, CH2, oxygen. Yes. It is called ethylene. Ethylene reacting with ozone forms ozonizer. Ozonize. Ozonizer. What is the name of this ozonize? Ethylene ozonize. It is called ethylene ozonized. Yes. By this way, ozonize will form. These are the chemical properties of the ozone. See what is the bond angle in the ozone structure? 100, 170. It is the what? Bond angle of the ozone. What about bond length? They given the bond length. Bond length here how much? 0.128 nanometers. So bond length also given. It is about the ozone. After oxygen in this group. After oxygen, which one element? What is the next element? Next element is sulphur. What is the atomic number of sulphur? Sulphur atomic number is 16. Sulphur showing allotrophic forms. Yes. What are the allotrophic forms of sulphur? Rhombic, monoclinic, plastic, colloidal. Yes. Sulphur showing allotrophic forms. Allotrophic forms of the sulphur. How many allotrophic forms of the sulphur? First one is rhombic sulphur. Rhombic. Second one is monoclinic sulphur. Monoclinic. Monoclinic. Plastic. Plastic sulphur. Monoclinic sulphur. Yes. Last one, colloidal sulphur. Yes. Colloidal sulphur. These are the allotrophic forms of the sulphur. Sulphur like carbon showing 4 allotrophic forms: rhombic, monoclinic, plastic, colloidal, sulphur. Sulphur is pale yellow non-metal, solid, odorless, tasteless, insoluble in water, poor conductor of heat and electricity. Viscosity: upon melting, sulphur is converted into a mobile yellow liquid, which turns into a dark brown mass. So it shows viscosity. There are several allotrophic forms of the sulphur available. Just now I said, these are the allotrophic forms of the sulphur. Yes. What are the uses of the sulphur? Sulphur useful in matchboxes, gunpowder. Yes. It is useful in pharmaceuticals also. Sulphur useful in pharmaceuticals. It is about the sulphur. Yes. Now, what are the sulphur forms? Sulphur forms hydrides, H2S. Yes, hydrogen sulfide. Same time sulphur forming H2SO4, oxoacids, H2SO3, sulfurous acid. Sulphur forming hydrides and oxoacids. Sulphur forming oxides also, sulphur dioxide, sulphur trioxide. Sulphur forms hydrides. oxides, oxo acids. Oxo acids. This is the information about the sulphur. Yes. Now, so what type of questions we can expect from this chapter? Yeah. What is the chapter name? 16th group. Yes. 16th group B. 16th group, in that questions mostly from hydrides. Next come to the sulphur allotrophic form, oxygen, ozone, preparation, chemical physical properties, sulphur, chemical physical properties, mostly chemical properties. So sulphur oxo acids questions we can see in our entrance JEE Mains NEET. Few questions we discuss now, few only, like this. The crystalline form of sulphur that is stable at room temperature. So monoclinic sulphur is the stable at room temperature. Coming to the next question. Yes. So what is the next question? Question number this. The oxidation number of oxygen in K2O, K2O2 and KO2. Yes. So generally the oxygen oxidation state generally normal -2. When it is peroxide -1. When superoxide -1 to 1/2. Yes. Oxygen is more electronegative element. In this group, it's showing oxidation state is negative -2. But when it is peroxide means oxygen bond is there. So oxygen single bond, that is peroxide, in that its oxidation state is -1. When it is superoxide, its oxidation state is -1/2. Generally -2 oxidation state. But in peroxide, superoxide, its oxidation number is changing. And yes, in textile industry, sodium thiosulfate is used as sodium thiosulfate used as a anti-chlor. Yes, it is acts as an anti-chlor in the industry. Anti-chlor. By this type of questions available, possible from the 16th group elements. Okay. So thank you students. This 16th group easy to understand, to learn, because it is inorganic chemistry topic. By one properties we learn easily, and solvation also questions easy from this chapter. Yes. Thank you.